Doppler effect and sonic booms. The Doppler effect occurs when a source of sound is moving with respect to an observer. So here's the fire truck at rest, and here it is in motion. So please click here for a nice introductory video on the Doppler effect. The Doppler effect is the frequency shift of a sound due to the motion of the sound source or the observer. A source emits a sound of a given frequency. If the source is moving towards the observer, put an observer over here, the observer hears a higher frequency or shorter wavelength sound than the one emitted. If the source is moving away from the observer, a lower frequency, higher wavelength sound is heard. Observer A, over here, in front of the fire truck, hears a higher frequency sound than the sound emitted by the fire truck. Observer B, behind the fire truck, hears a lower frequency sound than the sound emitted by the fire truck. And hopefully you can see the symbolism here. The wavelengths here are shorter, right? There's a smaller distance between them, which means that's a higher frequency. Behind, the wavelengths are greater, so that's a lower frequency. If the observer is moving with respect to the source, things are a bit different. The wavelength remains the same, but the wave speed is different for the observer. However, the effect is much the same. The observed frequency goes up as you go towards a sound source and down if you go away from one. Observer X is moving away from the stationary car and will perceive a longer wavelength and lower frequency than a stationary observer. Observer Y is moving towards the car and will perceive a shorter wavelength and higher frequency than a stationary observer. If a source is moving faster than the wave speed in a medium, waves cannot keep up and a shock wave is formed. So here's a stationary object with the waves emitting from it. If the object moves slowly, we get that same compression in the front that we've seen on the previous slides and an expansion in the wavelengths behind it. If it's moving at the speed of sound, it's right there. And if it moves faster than the speed of sound, breaking the sound barrier, then the source is actually moving faster than the sound waves it emits. And that's when you get a shock wave and a sonic boom. And this is best seen with the video here. So please click on that. Shock waves are analogous to the bow waves produced by a boat going faster than the wave speed in water. Aircraft exceeding the speed of sound in air will produce two sonic booms, one from the front of the airplane and one from the tail end of the airplane.